Hi, and welcome to this section of the Probability and Statistics Tutor. And in this section, we're going to begin to migrate from what we've been doing before, which is probability theory. Pretty heavily, we've been doing a lot of problems in probability. Now we're going to start to transition into sort of the statistics part of the class. And sort of this is a transition chapter here, and the topic of this is called mean, median, and mode. A lot of you may already know most of the stuff in here, but I'm going to cover it just to make sure we all have equal footing. And just to kind of give you the big picture, the first part of the class was all about probability and combinations and permutations and what are the odds of this happening, what's the probability of that happening, and all the rules of probability. The second part of the class is really dealing with what's called statistics, which is looking at large bodies of data and looking for trends. That's really the simplest definition I can come up with. So in probability, you may have a problem and I may say, what's the probability of this happening? And you go and calculate that. For statistics, I may have a sample database of 5 million data points about, maybe it could be the preferences of the American public. 35% of us like jelly beans, and 10% of us like popcorn, and 55% of us like our steaks medium rare, that kind of thing. But it's all based on large sets of data. That's why they do all these surveys. They call on the phone and they ask you all these questions, because mining that data from the population is very valuable, because the people advertising products to you are very interested. What percentage of us like jelly beans, and what percentage of us drive imported cars, and what percentage of us don't, and all of this. So statistics really is looking at, instead of a problem where you pick a probability, statistics is dealing more with large sets of data and the trends that you may or may not be able to pull out of that data. That's sort of the short answer there. So what we're going to do here is we're going to start making our way into that realm, and we're going to start talking about mean, median, and mode of data. So talked about that. The first thing I want to talk to you about is really a data set. So this problem is this chapter is really just going to be a lot of definitions and a few problems dealing with teaching you how to calculate a few things. The first thing, I just want you to be aware of that. That way we're all on an equal footing. A data set. What does that mean? A data set. Very simply, a data set is a collection of measurements. Okay, collection of measurements. So it could be, for instance, I go out and I go the parking lot at a grocery store, and everybody that comes into the grocery store, I take their temperature, stick a thermometer in their mouth, and I read the temperature. Some of us are going to have exactly 98.6 degrees. Some of us are going to have 98.4. Some of us are going to have 99. If you have a fever, you might have 101. So all of us are going to have a little bit different. But after taking 1,000 measurements, I could be said to have had collected a data set. Or maybe it's only 5 measurements. It doesn't really matter. But when I start collecting some information in a list of numbers, basically, it's called a data set. That's all it is. Okay. Another example that we're all pretty darn familiar with, every one of us watching this video probably, is grades in a class. Grades in a class. That's probably the most common data set, because all of us get different grades. Some of us get 90s and 80s and 70s and so on. And so the teacher grades the grades and collects that, and that could be considered to be a data set. It's just a collection of data. That's all it is. So what if we had, just to continue along this path, what if we had some grades in the class that we collected? And what if the grades were as follows? We have 5 students. Okay, and the grades are as follows: 80, 70, 55, 95, and 42. So we had 1 A, a B, a C, and 2 pretty low Fs, okay, basically. And so we have a wide variety of grades here, okay? One more term, this is just an example of what a data set is, okay? Another term that you'll probably see thrown about in your book is called population. A population is just a fancy word. It just means all available values of some data. Okay? So what it amounts to is at a university or a high school or something, I may have the entire grade history that this teacher has, maybe this teacher has taught school for 10 years. I may have all of the grades of every student that person has ever taught in her entire teaching career, or his entire teaching career. And I may have those data there, and that would be called the population. If I were going to look at this teacher's history of teaching, I would look at the entire population over all the years this person's been teaching, okay? A data set is simply a sub-collection of all of the data in the population. So these 5 values could be from, you know, just a few students in one class in the year 2008, but the population is usually much bigger. So that's just a definition. Population is all of the data. A data set is just some smaller collection of that data. It's really nothing more than that, okay? The next thing that's actually very important is the mean value. Okay, and I'm going to put this AKA average value. Most of you probably already know how to calculate the average value, but for those of you that don't, the way you do it is you just add up all values and divide by number of samples. So how would we find an average value of these grades that we have here? The way you would do it is you would say the average value is equal to 80 plus 70 plus 55 plus 95 plus 42, and I'm going to divide by the number of samples I just have here, 1, 2, 3, 4, 5 samples. Okay, so that's what I do. So then when I do this, on the top I'm going to have 342 over 5, and so when I do that division I'm going to get 68.4. That is called the average, okay? And what does that mean, just sort of when you think about it? I think we all kind of know what an average means when we're talking about grades, and that's why I picked this example. What it means is some grades are higher and some grades are lower. But on average, this is kind of the center, so to speak, of the distribution. We're going to use that term a lot over the next few sections, the distribution of the grades that you have. So you have some grades. Some are out way over here, some are over here, some people are good students and some are not so good. The average value is taking into account all of those grades and sort of trying to find that middle ground, roughly speaking. And the way you do that is you add them all up and you divide by the number of grades that you have, and that's sort of giving you that middle average of that average value, okay? So it gives you sort of a central value of the data. Now, one more thing I will tell you is the formal definition for the mean that you'll find in your book looks a little bit scarier, but it's exactly what I've told you. It's usually written as X bar. It just means that if your data is labeled X, let's say your grades are labeled, all the values are called X, the bar just means it's average value of X. That's all it means, okay? And what this means, the way you'll see it in a book, is the summation of the values, which is just X. I just told you the grades are X, so adding up the summation, the sigma just means adding up, that's all it means, your values of X, and you divide by the number n. The number n is the number of grades you have, the number of data points you have in your sample, basically. Okay, that's what it is. So this is what you will see in school, in your book, the summation of all of the data points divided by the number of data points, and that's exactly what we did here with our grades just up above. So there's nothing magical. You add them up and you divide, okay? Now what else do we have? There's also something called a median. We talked about the average value, which was sort of that average central value, taking into account the outliers on the left and the right hand side that may be way up there at 100, 102 and down there at 49 for the people that aren't doing so well. Okay? Median is if you arrange the samples in increasing order, the arrow means increasing order, okay, and you pick the middle one. Okay, so let's see how that would work out here. So my original grades that I had originally written down in the original order that I presented them to you were 80, 70, 55, 95, 42. Okay, so to find the median, first thing I have to do is rearrange my samples in increasing order. So that's going to be 42, 55, 70, 80, 95. And then the very last thing it says, I arrange them in increasing order and I pick the middle value. So the median is 70. And again, it's sort of like a central value as well. Now, normally when we talk about when we talk about averages in class and sort of everything to do with that, we're talking about literally the average value, the mean value, which is when you add everything up and you divide by the number, and it's sort of taking everything into account, giving you that sort of central value. This is simply the center number in the distribution. So it doesn't matter what numbers I have over here, and it doesn't matter what numbers I have over here. All I care about is which one's in the center. And that's why the median is not as useful, really, when you're talking about grades in a class, because what you're really trying to find when you're finding the average of grades is you're really trying to find how the class did as a whole, okay, as a whole. But here, if I just arrange the numbers and then pick the middle one, I'm not looking at what happened here, really, and I'm not looking at what happened here over here, really. I'm just looking at the center. And so this is the definition of the median, but it's not very useful when you're trying to actually find out how these students did as a class. And that's usually what the average is for, okay? So that's what the median is. Let me give you another example of a median and show you something here. Okay, what if I have the following grades? 72, 35, 49, 100, 65, and 80. Now let's try to apply the rule here and see if I can find the median, okay? So let's go in increasing order, starting, I guess 35 is the lowest one we have. So 35, 49, what else do we have? 65, 72, 80, and 100. So now I've got them in increasing order. Now I'm going to find the middle one. Okay, let's find the middle one. Well, 1, 2, 3, 4, 5, 6. I have 6 data points. Which one is the middle? Is it 65 or is it 72? It turns out that the median is real easy to find when you have an odd number of samples, because the middle one is in the middle. It's the one in the middle because you actually have one in the middle here. But down here, because there's an even number of samples, there's really not one or the other in the middle. These kind of are both in the middle. So really the way you handle that when you want to calculate the median of an even number of samples is you find the middle 2 and you take the average of those middle 2. Okay, so what you do is you say 65 plus 72 divided by 2. That's just taking the average of these center 2 values. So then what you're going to get is 137 over 2. Okay, so you're going to have 68.5 as the median. 68.5 is the median, okay? So the thing to take away with the median is it literally is the middle value. That's exactly what the median is, and that's kind of why it's named that way. I mean, when you're on the highway, the median is kind of the center divider, really. That's what the median is, okay? Well, it's in the middle of the road. Here, this value is in the middle of the road when you go in increasing order. If you line them up in increasing order and you can't find the actual middle value, you just take the middle 2 and you average them. Add them up, divide by 2, and that's going to give you the median right there. Okay, so far we've covered the average value and we've covered the median of a data set. Now we're going to cover what's called the mode, which is another thing that's really easy to understand. And the mode is basically the value in the data set that occurs most frequently. It's the one that occurs most often, okay? So to think about that, first let's go ahead and write it. The mode is the value in the data set that occurs most frequently. Okay, so again, let's work an example. So example data set 1. Let's say I have 70, let's make it 80, 70, 55, 95, and 42. And what I'm trying to find is which one of these numbers occurs most frequently. Well, this one occurs once, this one occurs once, this one occurs once, this one occurs once, this one occurs once. There is no number that occurs most frequently. So for this particular example, there's no mode. This is actually pretty unique. There's always an average value defined for a data set. There's always a median value defined, but there's not always a mode. And this is the example of when there's no mode, when there is no number that occurs most frequently. So let's contrast that to another example. What if I had 80, 70, 70, 39, 70, and 68? Which one of these occurs most frequently? I think you can convince yourself right away. 70 actually occurs 3 times. So the mode is 70, the number 70. That would be labeled the mode if you had to put an answer on your test. And then one final example on this real quick. If I had 83, 87, 83, 59, 87, and 42. Which one of these numbers occurs most frequently? Well, you can see right away 83 occurs 2 times, and 87 actually occurs 2 times. So the mode is 83 and 87. So for a mode, you can have more than one value, you can have no value, and you can have one value. So in this example, 83 happened 2 times, 87 happened 2 times, so they're kind of tied for first place for coming up the most frequently, and so that's why there's 2 modes in that problem. Okay, and the final one that we're going to talk about, just general sort of definitions with data sets, is called the mid-range. And basically what that means is you look at the highest value and the lowest value and you average those 2 values. You don't look at the middle values, you're just looking at the highest and the lowest and you average those 2 values. So the mid-range, if you had to write down more of a definition for it, would be listed as exactly midway between the highest and lowest value. Okay, now how does this compare with what I just told you? Well, let's go ahead and figure it out. Let's say I have a data set 80, 70, 55, 95, and 42. 80, 70, 55, 95, and 42. Okay? And if I'm going to rearrange these, because I need to find the highest and the lowest value, so let's go ahead and rearrange it. It's going to be 42, 55, 70, 80, and 95. 42, 55, 70, 80, and 95. So I've arranged them. The reason I've arranged them is because I want to find the highest and the lowest value, because that's what it says, exactly midway between the highest and the lowest value. Here's the lowest value, here's the highest value. How do you think you would find the mid-range of those 2 values? That's why it's called the mid-range, exactly in the middle between these 2. Well, you would just average those 2 values, 42 plus 95. And you would, to find the mid-range, you just average those 2 numbers. So when you have 2 numbers and you average them, what you're doing is you're finding exactly between those 2. You add them up, you divide by 2, you're finding the middle point between those. So 42 plus 95 divided by 2 is 68.5. And that is the mid-range. So what you'll see as you go through this example, this data set I use quite a bit, the mean, the median, the mode, they're usually not too far away from each other. The mean is sort of an aggregate representation of sort of the central value, so to speak, of the entire data set. The mode is the one that occurs most frequently. You have the mid-range that is basically halfway between the highest value and the lowest value, and so on. So you have these different little definitions. By far, the most important one is the mean. That's the one you'll find a lot, and that's the one that we're actually going to use a little bit later when we get into the probability distributions and the probability density functions. The mean value, that average value, so to speak, the one that you've grown up all your life with when you're talking about grades in the classroom, that's the one that's actually going to be most useful. These other ones here I'm just presenting mainly for completeness. The average value, the mean value, that's the one that we're mainly going to be using in the subsequent sections.